Welcome to this tutorial. I'm solving question number 7 of paper 2-1 May-June's exam series of 2020, and the topic of this question is radioactive decay. The question says two isotopes of carbon are carbon 12 and carbon 14. One of these isotopes, carbon 14, undergoes radioactive decay. Describe what is meant by radioactive decay. So radioactive decay is the emission of at least one of alpha, beta, and gamma radiations from the nucleus. So when the nucleus is emitting at least one of these types of radiations, this process is called radioactive decay. Carbon 12 has a proton number or the atomic number of 6 and nucleon number mass number of 12. Complete table 7.1 for a neutral atom of each of these two isotopes. So number of protons in carbon 12 is 6. Number of protons in carbon 14 would also be 6. Isotopes have same number of protons. Number of neutrons in carbon 12 is 6, but it would be 8 in carbon 14. It has 2 more protons, which makes its mass number equal to 14. Number of electrons are going to be 6 here because both the isotopes are neutral, so the number of protons and electrons must be equal to each other. A sample of carbon 14 is contained in a thin aluminium container of thickness 0.2 mm. So we are using a thin aluminium container of thickness 0.2 millimeters. Radiation from the sample is detected outside the container. So this thickness is sufficient to stop alpha particles if they are being emitted by any radioactive substance. If the radiation from the sample is being detected from outside, it means that some other radiation other than alpha, beta or gamma is being emitted. When the thickness of the aluminium is increased to 6 millimeters, now the thickness has been increased to 6 millimeters, which would be sufficient for stopping beta particles, but the gamma particle would still be able to go through. No radiation from the sample is detected from outside. State the type of radiation which is stopped by increasing the thickness of aluminium. So the type of radiation stopped is beta radiation or the particles. Explain how you know the sample does not emit one other type of radiation. It does not emit gamma radiations because they cannot be stopped by 6 millimeter thickness of aluminium. If they would have also been emitted, they must have been detected outside the 6 millimeter thick aluminium layer. So the question ends here with this part.
We try to explain complex concepts in simple language and with effective examples. If you like the video and the way we explain the subject, consider liking this tutorial, commenting on it and subscribing to our channel and press the bell icon, so that you stay updated and get notified when we upload more videos. Thanks for watching.